Hello friends, this question is from the subject of network in the topic of network solution methodology. It's a 2 marks question. The question says that find out the current I in a circuit such that voltage across R is 0. So voltage across R is 0. We need to find out the current I such that voltage across R is 0. First of all, let's discuss what do you mean by the current across R is 0. Current across R is 0 means there is a no current flow across R. It means the voltage across terminal, let's name this as A and this B, is equal. Or I can say this, that current across I, the current across, the effective current across resistor R is 0, means current supplied by the voltage source, 10 volt voltage source, let's name is I1, and the current supplied by the current source I, let's name this component as I2. So my this I1 and I2, I1 plus I2 should be equal to 0, such that effectively there is no current flow across R. So I will solve this question using superposition theorem. Superposition theorem says that if any linear bidirectional network you have more than one energy sources, so at a time you can consider one, and you can replace the voltage source, and you can replace other voltage source or current source by their input impedances. So here voltage source and current source are ideal. So for voltage source input impedance is 0, and for current source input impedance is infinity. So let's first, in first case we will consider, so in first of all we will consider the 10 volt, and we will replace the current source I by its input impedance, which is infinity. So we will replace the current source I with the open circuit. So let's draw the effective circuit for this case. 10 volt, 2 ohm, current source is open circuited, and here is my R resistor. 2 ohm, 2 ohm, 2 ohm. So I need to find out the current across this resistor R, which is I1. First of all, I need to find out the total current supplied by the battery, which is IT. It should be the effective resistor upon the voltage upon effective resistor. The effective resistor of the network should be, the IT is flowing is 2 ohm, and this 2 ohm and this R plus 2 ohm is in parallel. So my R equivalent for this network is 2 plus 2 parallel R plus 2. Okay, so my RTH1 will be equal to, if I solve this equation, it will be comes out as 4 R plus 3 upon R plus 4. Okay, this is my RTH1. Now if I calculate the I total, the total current of the by the voltage stored will be equal to the voltage supplied, which is 10 volt, upon resistor RTH1. So this will be eventually comes out as I total will be 5 by 2 R plus 4 upon R plus 3. So now I total, I need to find out my current I1, which is a component of I total. So let's apply the current divider at this node. So my I1 will be equal to the I total times resistance of other path, which is 2 ohm, upon total resistance, which is R plus 2 plus 2. So R plus 4. R plus 2 plus 2. Okay, R plus 4. You can write down I total into 2 of R plus 2 plus 2. So R plus 4 only. So now put the value of I total. So if I put the value of I total, then my I1 comes out as, after simplification, it will be 5 upon R plus 3. You can just put the value of I total here and solve it. You will get 5 upon R plus 3. Now, in second case, let's now replace this voltage source with a short circuit wire and consider the current I and find out the current in the branch of R. So let's draw the effective circuit in this case. So in this case, 2, 2, 2. So you can see that the direction of the current is, if I can name this node as A, as I have did earlier, A, and this node is a B. So direction of the current in first case is from A to B. My I1 is A to B. You can see. But now in my second case, my direction of my current is from, if I can name this node as a, it is as a B. So now in this case, because direction of the I is this, direction of the current coming from I will be, name as I double dash will be B to A. So my I double dash is in opposite direction of I dash. So my I double dash will be, if I may apply the current divider here, this 2 parallel 2 will be 1, effectively 1 ohm. So the current divider, we have two paths, one path with a resistor of 2 ohm, other path with a resistor of R plus 1 ohm. So I can apply the current divider here as 2 into I upon R plus 1 plus 2, which is 2I plus R plus 3, R double dash. You can simply consider this is two parallel 2 ohm, two resistors are in parallel, so they can be replaced by a 1 ohm resistor. So in my circuit I have a two paths for current source. For current source I, is one path for the with a resistor of 2 ohm, and other path we have a resistor of R plus 1 ohm. So I am applying current divider here. So I need to find out the current for the path of resistor R plus 1 ohm. So current divider says that the resistance of the other path plus total resistor. The resistance of the other path is 2 on total resistor. R plus 1 plus 2 is R plus 3. But I double dash is from B to A. On the other hand, my I dash is from A to B. So now effectively I know that effectively my I dash plus I double dash is 0, because I don't want any current flow across the resistor R. So the sum of I dash and I double dash will be 0, because superposition theorem says that we need to find out the current regarding each and every independent sources, and then we need to sum it to find the effective output. So right now I am adding the two currents, but I know that the direction of the currents are different, so they were, instead of the addition they will be subtract. 5 plus R plus 3, and I double dash will be minus 2I plus R plus 3, because I dash and I double dash has the opposite sign. So if I may transfer the R plus 3, so I can simplify this equation as 2I is equal to 5, which comes out I is equal to 2.5 ampere. Means that if my current source I has a value of 2.5 ampere, then in the resistance with the branch of R we have effectively no current. So my correct option is option C.